In the last set of videos, we looked at gravitational potential energy as a definition and an idea. In this video, we're going to derive an expression for the gravitational potential energy of an object at a height h. The case that we are handling is near the surface of the earth. Okay, so the same expression can't be used when we have objects a lot above certain height. Okay guys, if you pass certain altitude, we can't use the same expression. So we have the earth over here and we have the object over here. So somewhere along the line, right, if we keep the object over here, point P, okay, the question is, what is the potential energy at this point P? So this is of mass m, and the height that we lifted, or the object is h. From the surface of the earth, it's at a height of h. So what is the potential energy of this particular object as of now? That's the question. So how is that we are going to derive this? The basic idea is quite simple. We know that work and energy, the idea and the concept and the nature is interchangeable. That is, if I do work, the other object gains energy. If someone does the work on me, that is, they're spending energy on me, right, I'll gain the energy. Okay, so the work and energy, the idea is the flow is interchangeable. Since I want to find the energy, what I can do is I can do reverse engineering. I can figure out the work of doing what? Of lifting the object from point A to point P. See, the point is, when I leave the object from point P, it will fall to point A, right? Is it not? Because it has that amount of energy. So by doing the other way around, by working on it, what will I do? I'll be able to figure out the energy. So if I spend 10 joules of energy, right, if I spend or do a 10 joules of work, the energy would be 10 joules. As simple as that. Okay guys, so what is the work that I'm doing by lifting it? Well, it's equal to F into S itself. S we know, S is nothing but your height. But what is F? What is the force? That is quite simple. If you remember few numericals, I'll give you guys a clue. Let me draw a free body diagram of an object which is being lifted. Okay, I'm lifting the object. During that time, I'll draw a free body diagram. So one of the forces that we know is the weight, which is equal to m into g. What is the other force? The other force is us lifting. So how much force should it be? Well, one thing is it has to be more than mg. Should it be a lot more than mg? Or should it be almost equal to mg? You know, a bit more than mg. That's the question. What do you think is the answer? Well, let me show an experiment to make you guys understand this. So what is the answer? If it's too much, what happens is, see, if I have to lift an object from point A to point B, if I do it really fast or try to do a lot of work or spend a lot of energy, what happens? The excess energy will make the object fly. That's what happened in that video. The pencil, I had to just lift it to a particular height, but because I lifted it very fast, what happened? I did a lot more work, right, than what is required, and the work exactly will not match the potential energy because it flew away, is it not? It went to a different height altogether. So lot more than mg is not a good idea. A bit closer is a decent idea, is the right idea. But since we are talking about ideal scenarios, we are looking at force which is almost equal to mg. It should be very, very, very close to mg, so we can equate it to mg. Again, we are talking about an ideal scenario, So it is very close to mg. So we can just equate it to mg. Like ठीक है चलो मतलब we are doing a bit more energy, that is almost equal to 0.0000 something 1 joule or something. So we don't need to handle to that extent. So this is good enough. So now we have the work which is equal to mg into h. And we just spoke over here that what work we did, all of that will be converted to our gravitational potential energy, which is equal to mgh. Okay guys, that is our expression. That's it. That's the whole idea. Got it? This is our idea, but yes, theoretically, how is that we're going to write? Consider an object of mass m. Let it be raised through a height of h from the ground. So this is our ground. This is of mass m. It's moved from point A to point P. Okay, yes. And the difference between point A and B is h. So that's our initial condition. The force that we are applying is to lift an object, we require a force, which is true. The minimum force required to raise the object is equal to the weight of the object, which is mg. Sounds right? We just saw that. By doing so, we are lifting at an infinitesimally slow speed. Okay guys, this is a new fancy word. When I found this, even I was like, it's nice. You know, it uses the word infinity, but it means very small or slow. Infinitesimally is very, you know, small. The word infinity is huge, right? In general, infinitesimally slow mean very slow. Okay, that's what it means. You guys need not write it. I just thought, you know, it's fun to let you guys know this word. So all we have to write is from this point to this point. So the object is being lifted infinitesimally slow, right? So by doing so, what is that we are looking at? We are looking at a free body diagram wherein the object is being pulled down with a force of mg and it's pulled up with a force of mg, almost equal to mg. Okay, it's happening very slowly, but slowly it will move up. And by doing this slow work, all of our work gets converted to gravitational potential energy and none of it will be wasted in any other form. Now the energy part. The object gains the energy equal to the work done on it. Is it not? Justification is as per law of conservation of energy. Let me write it over here. Law of conservation of energy. Okay, yes. So this is something that you might know by now. If not, I'm going to explain it a bit later in the different set of video. Actually, it's in the topic itself. So it's not difficult concept. It's actually quite simple. Okay. So if you don't get this law or you don't remember this, it's okay. Right. And now the expression. Let the work done on the object against the gravity be W, which is equal to force into displacement. Force we just found out is mg and this is h, mgh. And the conclusion is, since the work done on the object is equal to mgh, an energy equal to mgh units is gained by the object. That is the gravitational potential energy is equal to mgh. That's your derivation. That's it. Okay, quite simple. So here you guys have to write down the heading, nothing else. Okay, all of this is just for, you know, ease of explanation, a single slide. But you guys have to write this answer in your exam.